Hello friends, I welcome you in lecture number 6 on partial ordering. In this lecture we are going to discuss about hash diagram. We have seen how to represent a relation using directed graph or diagraph of the relation. So for partially ordered set, we are having hash diagram for their representation. We can represent relation using diagram, and for partial ordered set we are going to represent them by hash diagram. So we will see how to plot or how to draw the hash diagram of a partially ordered set in this lecture. Now before going for hash diagram, we recall this notation which we have discussed in lecture number 5. For every partially ordered set or for every partial ordering denoted by less than or equal to, we can associate another relation which we denote by this notation less than, and for x y belongs to P, we know that x is less than y if and only if x is related to y but x and y are not equal. So we are going to use this notation for representing partially ordered set by hash diagram. So remember this notation: x less than y if and only if x is related to y but x and y are not equal. We are going to define cover of an element also. Suppose we want to define an cover of an element, say x. Suppose we want to define cover of some element in a partially ordered set P. So cover of that element is also another element in a partially ordered set P, say y. So we can say that y is a cover of x, or y covers an element x if x is less than y and there is, if x is less than y and there is no z in partially ordered set P such that x is related to z and z is related to y. I repeat again, we can say that an element y covers an element x if x is less than y and there is no z belongs to P such that x less than or equal to z and z less than or equal to y. So we understand this definition using one example. Suppose we consider divisibility relation on this set, which is the set having these integers 1, 2, 3, 4, 6, 8 and 12, and we are considering this as our partially ordered set P, and we are considering this divisibility relation on this set. Now we can see that here if we consider these two elements 2 and 4, then I can say that 2 is less than 4 because 2 divides 4, that is 2 is related to 4 and 2 and 4 are different. So 2 is less than 4. 2 is less than 4 means 2 is related to 4. Here relation is divisibility relation. So we know that 2 divides 4, therefore 2 is related to 4 and 2 is not equal to 4. Therefore we can write that 2 is less than 4. Now we are interested that whether 4 covers 2 or not. So 4 covers 2 if 2 is less than 4 and there is no element z in a given set P such that 2 is related to z and z is related to 4. Here our relation is divisibility relation. Therefore, I replace this notation by this symbol 2 divides z and z divides 4. We can say that 4 covers 2 or 4 is a cover of 2 if 2 is less than 4 and there is no z in given set P such that 2 divides z and z divides 4. So here we can see that between 2 and 4 there is no element such that 2 divides that element and z divides that element. We can see here divisor of 4 are 1 and 2 only. So here 1 is divisor of 4 but 2 cannot divide 1. So I cannot say that this z equal to 1. For z equal to 1, 2 cannot divide 1. So 2 does not divide z. So we can say that there is no z in between 2 and 4 such that 2 divides z and z divides 4. Therefore 4 covers 2, or 4 is a cover of 2. Similarly, we can check for any other elements. For example, if I consider 2 and 8, then if I take 2 and 8 and I am interested that whether 8 is a cover of 2 or not. So 8 is a cover of 2 if 2 is less than 8. 2 is less than 8 means 2 divides 8 and 2 and 8 are different. So this condition is satisfied that 2 is less than 8 and there is no z in between 2 and 8, that is 2 less than or equal to z and z less than or equal to 8. So instead of less than or equal to, we write this divisibility relation that 2 divides z and z divides 8. So we have to check whether there is any z between 2 and 8 such that 2 divides z and z divides 8 and this z is equal to 4. We can see that there is a 4 between 2 and 8 such that 2 divides 4 and 4 divides 8. Therefore 8 is not a cover of 2. So this is the meaning of a cover, and this definition of cover is very important in the drawing of given hash diagram of a given partially ordered set. If you are able to understand this definition, that when we can say that one element covers another element, then you are done. You can easily draw the hash diagram of a partially ordered set. So I repeat again that if I have a partially ordered set with say partial order less than or equal to, then x less than y if x is related to y and x is not equal to y, and y covers x if x is less than y, that is this condition is satisfied and there is no z in a given set P such that x is related to z and z is related to y. If this happens, then we say that y covers x, and these two things are very important in the drawing of a hash diagram of a partially ordered set. So once you have understood these two terminology or these two definitions, you can easily draw the hash diagram of a partially ordered set, whatever relation is given. So we try to draw the hash diagram representing the partial ordered pair AB such that A divides B on the set 1, 2, 3, 4, 6, 8, 12. And this question was asked in GTU Winter 2020 exam. Now to draw the hash diagram of a given partially ordered set, first thing is we have to represent each point of a given partially ordered set by a small circle or by a dot. So we can represent each point by a small circle, or we can use this type of dot also. Now if x is less than y, this means x is related to y and x is not equal to y. If x is related to y and x and y are different, then circle for point x is drawn below the circle for point y. If x is less than y, then circle for element x is drawn below the circle for element y. So this is second point. First point is each point is represented by a small circle or a dot. Second point is if x is less than y, then a circle for x is drawn below the circle for y. For example, here we know that 3 divides 6 and 3 and 6 are different. So this implies that 3 is less than 6. So circle for 3 will be drawn below the circle for 6 in that sense. And the last important thing is if we have two circles which represents two elements, then we will join these two elements by a line, or a line is drawn between x and y if and only if y covers x. If y covers x, then only line is drawn between x and y. If y does not cover x, then we will not draw a line between x and y. We will simply represent them by x and y. However, they will be connected by some other arrows or other lines. So remember these 3 points for drawing the hash diagram. Each point is represented by a small circle or a dot. And second point is if x is less than y, then circle for x is drawn below the circle for y, and a line is drawn between x and y if y covers an element x. With these 3 points in our mind, we try to draw the hash diagram representing the divisibility relation on this set. It is easy to see that or we have shown that divisibility relation is a partial ordering relation. Therefore, this set is a partially ordered set under divisibility relation, and therefore we can draw the hash diagram. It is already given that this relation is a partial ordering, and this question was asked in GTU Winter 2020 exam. So first thing we have to decide is that here I have 1, 2, 3, 4, 5, 6 and 7 elements. So I will have to draw 7 small circles. Now we know that 1 divides 2 and 1 and 2 are not equal, and also there is no z in between 1 and 2. There is no element z such that 1 divides z and z divides 2. So I can say that 2 covers an element 1. 2 covers 1. Therefore, the circles for 1 and 2 will be joined by a line segment, or a line is drawn between 1 and 2 because 2 covers 1. Similarly, I can see that 1 divides 3 and 1 is not equal to 3, and this is also correct. There is no z such that 1 divides z and z divides 3. There is no z in this set such that 1 divides z and z divides 3. Therefore, 3 also covers 1. So we have to consider a line between 1 and 3. Now here also for element 4 I can write that 1 divides 4 and 1 is not equal to 4. But 4 does not cover 1. Why? Because 1 divides 2 and 2 divides 4. There is a 2 in this set such that 1 divides 2 and 2 divides 4. Therefore, 4 cannot cover 1, and therefore we will not consider a line between 1 and 4. So here we have seen that 2 and 3 are covers of 1. So we will consider 1 below the circles of 2 and 3, and we will join 1 and 2 by line and 1 and 3 by line. So let me finish that part first. I am considering small circle which represent 1, and here I will write down 2 and 3, and because 2 covers 1 I will join 1 and 2 by line, and a line is drawn between 1 and 3. So again I repeat, because 3 covers 1, a line is drawn between 1 and 3, and because 2 covers 1, a line is drawn between 1 and 2. Now other elements are 1, 2, 3 is now drawn. Now then other elements are 4, 6, 8 and 12. So now we check for 2 and 4 whether 4 covers 2 or not. So 2 divides 4 and 2 is not equal to 4, and there is no element z between 2 and 4 such that 2 divides z and z divides 4. So I can say that 4 covers 2. So suppose I consider a circle for 4, then I know that now 4 covers 2, so a line is drawn between 4 and 2. Similarly, I can see that this 6 is a cover of 3. 3 divides 6 and 3 is not equal to 6. This implies 3 is less than 6, and there is no z in this set such that 3 divides z and z divides 6. Therefore 6 covers 3. So I will consider a line between 6 and 3 also. Next elements are 8 and 12. So we know that 8 cannot divide 12. So 8 is not related to 12. And we know that 4 divides 8 and 6 divides 12. 4 divides 8 and 4 is not equal to 8. Therefore 4 is less than 8, and there is no z between 4 and 8 such that 4 divides z and z divides 8. There is no z here such that 4 divides z and z divides 8, because here 4 divides 8 and 4 divides 12. So if I consider z equal to 12, then 4 divides 12, but 12 cannot divide 8. So I can say that 8 is a cover of 4. 8 covers 4, and therefore I will consider a line segment between 4 and 8, and you can check that 12 covers 6. 6 divides 12 and 6 is not equal to 12. Therefore 6 is less than 12. Therefore circle for 6 is drawn below the circle for 12, and there is no element z in a given set such that this happens. So this is not correct. Therefore 12 covers 6, and therefore a line is drawn between 6 and 12. So in this way we have to join every element to its cover, and let me check whether I am missing any covers to be joined by element whose cover are those elements. For example, here if we check for 2 and 6, then we know that 2 divides 6 and 2 is not equal to 6. Therefore 2 is strictly less than 6, and there is no z in given partially ordered set such that 2 divides z and z divides 6. We can see here 2 divides 4, 6, 8 and 12, and we cannot have any z in the given coset such that 2 divides z and z divides 6 here, because if we take z equal to 4, then 2 divides 4, but 4 does not divide 6. So there is no element z in this set such that this happens, that is 2 divides z and z divides 6. That means 6 is a cover of 2. So I have to join 6 and 2 by line segment. So in this way I have to take care of every element. I have to join every element to its cover. Similarly here also I can see that 4 divides 12 and 4 is not equal to 12. Therefore 4 is less than 12, and here also there is no z in given set such that 4 divides z and z divides 12. There does not exist any z in the given set such that 4 divides z and z divides 12, because here 4 divides 8 also, 8 only, between 4 and 12. So 4 divides 8, but 8 does not divide 12. So we can say that there is no z such that 4 divides z and z divides 12. Therefore 4 is covered by 12, or 12 is a cover of 4. Therefore I have to consider line segment between 4 and 12, and this 8 and 12 are not related, so I will not consider any line segment between 8 and 12. And because they are not related, the circles for 8 and 12 are in parallel. Similarly, circles for 4 and 6 are taken as parallel, and same thing for 2 and 3. In this way we can consider, or we can draw the hash diagram of a partially ordered set together with given partial order relation, and this is the final hash diagram for given poset under divides relation. So what we have to remember, that we have to draw the circles for every element of a given partially ordered set. Then we will consider the circle for x below the circle for y if x is related to y and x is not equal to y. Similarly, we will join y and x by line segment if y is a cover of x. Y is a cover of x if there does not exist any z in the given partially ordered set such that x divides z, or x is less than or equal to z in general, or x is related to z and z is related to y. This is very important. Cover of an element. Y is a cover of an element x if x is less than y and there is no z in between x and y such that x is related to z and z is related to y. And we join two elements x and y by line segment if one element is cover of another element, and the circle for x is drawn below the circle for y if x is less than y. In this way we can draw the hash diagram of a given partially ordered set, and this is all about this session. I hope you like it, and we will continue with hash diagrams in upcoming lectures. Thanks for watching.